Why did you guys get started with this?
Um,
What's
we
driving you?
we both listen to a lot of podcasts, and I've been using Python for a while. Chris has been interested in it for a while. He's recently started using it, and there just haven't been any Python podcasts out in the wild for a while now because all the ones that had been around stopped producing any new content. So we decided, hey, why not us?
Cool. You
Yeah,
bet.
it was definitely one of those things where I feel like Python has such a thriving community, and I listen to other podcasts or other stacks like the Ruby Rogues and things like that, and I just thought to myself, it is a crying shame that Python doesn't have something in this space to sort of like to do outreach to people, because there are a lot of people who, while they're working out or driving or whatever the case may be, they listen to podcasts to keep informed.
Hello, and welcome to podcast.init. Thank you for joining us. Today we are recording on April 28th, 2015. Your hosts, as usual, are Tobias Macy and Chris Patty, and tonight we're interviewing Travis Oliphant.
Travis, why don't you introduce yourself?
Oh, thanks. I appreciate being here, Tobias and Chris. It's a pleasure. My name is Travis Oliphant. I've been working with Python since 1998 about. Well, for a long time. I was a scientist, really, or someone passionate about engineering and science, and came across Python as a graduate student. Really loved it. Ended up getting pulled in and getting addicted to the open source community and the ability to change the world through interactions with the community, and have been a part of the scientific community ecosystem ever since.
So I'm curious what inspired you to create NumPy and SciPy, and why you chose Python for creating those libraries.
Yeah, so SciPy was my real passion when I was a graduate student. I was studying electrical computer engineering and then biomedical imaging at the Mayo Clinic. And I had 5-dimensional derivatives I needed to take, and I wanted to do it at a high level and not have to write C code all the time. I could write C, I could write Pascal, but I really liked this expressivity of Python. I had an experience basically. I started to use it, and then a year later I came back to code I'd written previously, and I could still read it, which is the opposite experience I'd had with Perl 3 years earlier, when I'd written some Perl code to do some high-level manipulation of scatterometer data coming off of a tape. And then I went back and tried to look at the code that I'd written. I didn't understand it, my own code. So that kind of, for me, I remember that moment when a year later I looked back at the same code and I said, I get this still. And I went, and I had this really unusual feeling of kind of loving to program, like, and having fun with it. I don't know, because it felt powerful. It felt like I could do things quickly and I could connect. People have expressed this in many ways, like it fit in your head, it didn't get in your way. It left room for you to think about your problem rather than the programming. I don't know exactly all the reasons, but for me, I was hooked, and I got excited as a student to be able to create more. So I looked around and said, I want to be able to do ordinary differential equation solving. I wanted to simulate an MRI machine, and I needed the fundamentals of an MRI is the block equations, which simulate the magnetization vector. It's a fairly straightforward simulation, but I needed an ordinary differential equation solver. Didn't exist in Python. So I went out and found one on the internet. It was written in Fortran, and I connected it to the Python interpreter by writing a C extension by hand. Basically, I wrote a C extension to Python by hand to connect that Fortran code, so I could call it from high level and specify the equations in Python, but have this Fortran solver ultimately do it. That was sort of the start of SciPy. I ended up connecting an integration solver and some optimization libraries and released them as MinPack in 1999, roughly. So I was just excited about the possibility to create this cool library that lets you do high-level coding and programming, but in a language that was open, and you could then share and other people would use it. So that was a start. I got excited with SciPy. Then as I graduated and I got a job as an assistant professor at Brigham Young University, there was some energy around basically in the community there was a new array object being promoted called NumArray. And when I had joined the Python ecosystem, numeric, written by Jim Huguenin, was the array object that I used and built SciPy around. So NumArray was this other array object that was kind of emerging, promoted by the Space Science Telescope Institute. It had some improved features they needed. And then then one day I saw basically a library came out, a library I'd always wanted. It was a morphology library, and I was a medical imaging student, and I really wanted a morphology library in SciPy. But it came out for NumArray. And at that point I went, oh, we're building these two communities of different libraries on different array objects. And I became frustrated. I was like, oh, this is not good. And so that happened to coincide a few months or two later with a class I was teaching canceled, and so I was left without a class. I had 4 months of no class and just my research to work on. And so couple that with this itch and this passion to merge these communities, and the feeling that I'd been the only one kind of around long enough, I felt that would be able to do something about this. So I kind of felt an obligation, a duty, and then a desire to work on it.
That's really great. It's interesting. I worked for the Human Genome Project quite a number of years back at this point, and at that point in time, everyone there was sort of graduating on from this kind of crusty old Perl, and everyone was really excited about the potential for using Python in that sphere. So based on the timeline that you're mentioning, it seems like there were a whole bunch of things sort of coalescing and coming together to really sort of provide for kind of a Python explosion in the sciences that happened all around the same time.
That's right. It's exactly right. There was. This is about 2006 that I wrote NumPy, which built off of numeric and pulled in the features of NumArray. So to me, that was a very important, critical moment because it was a challenging thing to do. I was not trained as a developer, as a computer scientist. I was a scientist. Cared about what people did with the code. I had learned enough C and written and seen enough of the Python C if you had to be dangerous. Became a core Python developer at the time to actually move and try to promote some of the Python or the NumPy array structure into Python itself to avoid any future problem of array incompatibility. So there's a lot of work I did around that time. It was a real learning experience for me to kind of understand kind of what software engineering and architecture is like. I made mistakes, but if I'd known what I know now at the time, I would have done things a bit differently. But that's the great thing about the Python community is people, they dive in where they can and they support what they can do and then move from there and iterate. So yes, about that time. So around that time, also, John Hunter had created Matplotlib. In 2001, we put together SciPy out of the early work I'd done in '99, kind of organized a library of tools. So you started to get this critical mass, and then IPython interactive environment was also emerging at the time. And after 2006, kind of creating NumPy really helped kind of solidify this is the array object. Everyone agrees. I did a lot of work to try to just organize community and really and the work was a lot of writing code, a lot of writing examples, a lot of writing documentation, a lot of writing emails to try to encourage everybody to use it. And I remember when John Hunter removed his support for NumArray and numeric, it was just NumPy he supported in Matplotlib, and that was about 2007, and that was a big deal. And then sort of everybody followed suit, and then the explosion occurred of a lot of things came together, as you said. It was and definitely one of the great things about the Python ecosystem is how many people have participated in making it great. And the scientific computing system is no different. Although it does take individuals taking risks, it was not good for my academic career to spend time on NumPy. None of my folks who would eventually vote on my tenure application cared about NumPy. But I felt like it was the right thing to do and the important thing to do for the world. So
we're certainly glad you did.
We're definitely all happy that you did that because it has certainly become the basis of a large amount of scientific and numerical code in Python, and even people who aren't necessarily doing any hard science or incredibly complicated maths have definitely found some uses for it.
Yeah, and you look at Pandas is a similar story, right? If you talk to Wes, you'll hear a data frame story, and a lot of other folks are using data frames, but he wrote one and got his employer to let him open source what he had worked on, and now it's become the standard for people doing data analysis. These stories, and John Hunter before him with Matplotlib and Fernando Perez and Brian Granger on IPython. You just see the scikit-learn team is another one that's just exploded since 2009. It's just fantastic to see all of this. But it does take effort. I guess that's the thing I want to definitely emphasize. Somebody has to have the courage do and to act, even in the face of uncertainty. And once you do that, and not everything you do also succeeds, right? Sometimes you write something and it's the wrong direction, but if you're listening open to feedback, you can usually get it. NumPy, everybody wanted it. Everybody was excited about it. They were unsure it could be done, but once I started making progress and people could see I was going to make it, then I got a lot of support.
I'll bet. So, for those who aren't in the know, can you provide a brief description of what data science is and how you got involved in it?
Data science, man, that's a term that was coined by DJ Patil. And so it's being used as a coalescing point for a general concept of anybody that takes data and tries to get insight from it. It kind of becomes this. Most people who are data scientists do a little bit of applied mathematics, a little bit of system administration, a little bit of coding, programming. They kind of put it all together and have to kind of do a little bit of all three. So, data science is a popular term, but I think a lot of people don't really know what it means or what it is. If I look back at what I was doing in graduate school, I was taking scatterometry data from satellites and estimating wind speed. Right? That was data science to a degree, so science has been doing data science for a long time. But currently today, it's more popular because now the business professionals are doing it too. The marketing folks are doing it too. The people looking at their logs are saying, oh, we got to get information from this to know what to sell to people. So it's got more money around it now, and so people use it. The cool thing is that these tools we use for the scientists, like NumPy, have now this application to a much larger group of people. And Python, because it's so accessible to people besides just scientists and programmers, it's accessible to even business analysts with the right tools around it. Now they're interested. Now this whole ecosystem is now made available to a lot more people. So that's exciting.
Absolutely. And talking about I have two things to say. The first is it's interesting. You talk about data science kind of becoming this almost sort of like supercharged term that the marketers have picked up. It's funny how many of those there are, and it seems like they've really become more and more common in recent years, things like cloud or DevOps. And it's like you have this core group of people like yourself who built this thing that does a thing, and and it fills a niche, and suddenly like a term gets applied to it, and then it kind of takes on a life of its own and takes off. So that's
And, for data science, Pandas has been really helpful to kind of orient. Pandas builds on top of NumPy and orients it towards a particular audience that needs, like NumPy is a multidimensional array, right? And, I'm very excited about the multidimensional aspect of it. I've been doing 5-dimensional derivative calculations in grad school. That's why it was in my head at the time. But Pandas is it's a 2-dimensional table, right? It's a very simple structure. And you could do it in NumPy, but Pandas added an API on top and a few operations that were very simple, and it made it more accessible. And that's kind of been I think Python generally makes it easy to create objects and structures that make coding and calculations accessible to others. And there's still a rich opportunity in a lot of spaces to do that. That's what's exciting, is it's not done, not by any means. I've always been passionate about creating technology solutions that let even more get built around it. Kind of looking at the fundamental blockers that are causing disconnects, and then try to resolve some of those so that we can get a cooperative explosion on top of additional ideas. So that's still available right now. And Python, it's still the right language to do it in. It's still it's got its challenges. It's there's lots of things I'd love to see different in Python, but it's got a critical mass. It's accessible. People can understand it, and it's still a great language for all of that.
Absolutely, and I really think, sort of dovetailing what you were just saying and the point you made previously about these tools having wider, and broader applicability, I've been seeing in the last few years. I work in the infrastructure as code space. I do a lot of work with things like Chef and Ansible and SaltStack and all that kind of thing, and it's been really interesting watching people who build care and feed for infrastructure sort of really start to leverage some of these amazing tools for data science in terms of visualization, and because it's really easy to end up with these huge masses of data that it can become very ungainly, and all of a sudden when you can apply these, hey, scientists have been dealing with this stuff for longer than we've been alive, and we now have these amazing computational tools that make it easier than falling off a log. It's really cool to see what happens when people from all kinds of different, disciplines, fields, and industries start to leverage this stuff, and only goodness can result.
I agree. Python has allowed a lot of people to cooperate in building interesting tools that otherwise wouldn't talk to each other. That's a very interesting aspect of Python.
Yeah, it definitely seems to have become sort of the lingua franca of anybody who's trying to do integrations between a large variety of problem domains because of the myriad different libraries that are available for it, and the power and flexibility of those libraries.
Yes. Python got its strength as glue, and I think we've just started to see how super glue that will be. It's sort of a glue that becomes like Legos.
It's funny that you mentioned Legos, because when you were talking about leveraging these core components that can get built out in more general ways, one of the architects where I work, he likes to use that term, but the truth is it's a really good term, especially for things like this that people just combine in really interesting ways. And you look at a little kid with a pile of Legos, and it can be kind of amazing what they come up with sometimes.
Yes. Yeah. Just like with Legos, sometimes, like one thing about being Pythonic, right? I've heard that word for a lot of years. One angle of being Pythonic is having the right structure in your Legos, right? They can connect with each other. Right. You want to make sure you can build on top and have different layers of abstractions. So yeah, that's it's powerful. So I'm really excited still to be a part of the Python community, and it's been a tremendous ride, and I'm still pretty passionate about it.
Great. So can you tell us some of the story of how Continuum Analytics came to be, and sort of your mission with that company?
Yeah, so I started in academia and really love open source. Realized that, but I also love markets. In my mind, open source is too valuable to the world to be left to just volunteerism. And so I want to figure out and support any efforts in the marketplace to connect what we buy to what gets built in open source as well. So I left academia about 7 years ago, went to the industry and started working as a consultant. And in the process saw a lot of opportunities that open source was solving problems that businesses needed. And so over that time, built up some ideas, particularly saw an opportunity in bringing these tools to the data analytics world. And so Peter and I created Continuum to connect the scientific codes that we are very aware of and have been a part of to the larger data analysis problems, in particular to helping experts everywhere build tools faster and easier. Our motto is to connect expertise to data, our mission, our goal. A lot of people believe that there's going to be a magic, I don't know if they believe it or they hope it. I mean, I would love it too if there was some magic predictor that could take your data and just give you results. You have that, here's the data input, and then output comes exactly what I need to do next. Action statements. We're a long way from being there. I think in some cases you can get close, but generally what's needed is the ability for people who understand the domain to quickly put together solutions they can iterate with quickly, because the data changes, the problems change, and you need to come to an answer soon and quick and as fast as possible. And Python's ideal for that. So our mission is to use Python and build on Python to make it easy for people to build solutions that includes dashboards and visualizations and even to full applications very, very quickly from the large data they have. And so that was the idea around Continuum, and so we wanted to support open source. One of our metrics of success is how many open source projects we're contributing to and releasing, because that's one of our reasons for existing, is to keep building this community that I find so compelling in the world.
Well, I think by that metric, you guys can be considered to be a raging success. I mean, I'm not really as well versed in this area as my co-host here is, and Tobias was filling me in on. I'd heard of Numba and NumPy, but I had no idea that you folks have a whole little mini universe of projects that you folks have brought into the community. It's kind of impressive and really cool.
I appreciate that. I mean, we do try to focus a little bit around visualization. Bokeh is our visualization tool, and the goal there is to make you not have to write JavaScript. You can write Python and then have interactive visualizations in the browser. And then Blaze, I'm real excited about Blaze. Blaze is a topic for another podcast, though. It's all about helping people write expressions at a high level and translating to the back end where the data sits. It solves the problem of currently today when people have data problems, the first question they ask is, where's my data? Because that defines how they talk about their data problem. If it's in a database, they write a SQL statement. If it's in CSV files, they write some parsing code. If it's in HDFS, then they either do Spark, or they write some Hive, or they do something different, depending on where it is. We don't think it should be that way. We think you should have an understanding of your data as a high-level object, data frame or array, and then write your code. And then the back end, it's where it sits is a implementation detail. And you can map your expression to wherever it sits. So much like SQL Alchemy does that for data in databases, Blaze does this for data everywhere.
That's really neat. So when you say, I like your analogy of likening it to SQL Alchemy. I guess a question that I have is, what I really need to do is after the show go look it up and get some more detail. But can you give me like a potential use case? Like, what is a real world problem that someone might have that Blaze would elegantly solve?
There's a couple that it elegantly solves today. I mean, one is I want to translate data from one form to another. A lot of people don't try out the tools that are available, don't know the difference between a Cassandra or a Hive or a Spark or a SQLite implementation, or using bcalls and pitables. You know, they typically get stuck with the current data format they have, and they don't realize they could be having huge performance gains. They use a slightly different backend and maybe adjust the approach they're taking. And Blaze makes it easy to try them. You can take your data, you can write a high-level expression, use your query, and then you can quickly port it. Say, okay, I'm doing this with SQLite, or I'm doing it in my table in Oracle, or I'm doing it with a bunch of CSV files. What if I just converted all this to HDF5 files, which is a scientific data format, and then ran my query? Could I be faster? And it lets you test that out very, very quickly. Within a few lines of code, the back end is switched, and your same query runs on that new set. So it lets you switch backends very quickly and migrate data quickly. There's a sub-project in the Blaze ecosystem called Odo. Odo does the extract, the copying of data. It's almost like you're saying copy, but you don't have to do all the work. You just say, here's my URL to the CSV file collection in this directory, and then here's my URL to a bunch of tables in Hive, and it'll copy them. It'll just do the transform for you, and then you can run a query on it. And a query is a table expression. So if you're used to the Pandas API, you can write a Pandas API-like expression, and now it runs on the data in Hive. You don't have to learn Spark. You don't have to learn MapReduce. You don't have to learn a new system. You can just use the same high-level interface.
That is super cool, and that's definitely a problem that a lot of people in a lot of fields are having, like where they realize, gee, our performance stinks, and we're using a SQL database for this, but really the way this data is being used isn't relational at all. Let's go explore a NoSQL. But that's not something as trivial as saying, hey, change the back end out. Like, there's a lot of work involved there. Yes. And so to be able to sort of like toggle and try something else, that's potentially life-changing for people.
Yeah, that's really amazing. It definitely
that's our goal. And in many cases, we reach it, right? I'm not going to say it's like mapping to a different data set. Depending on how large your data set is, you have to transfer it. You have to you do have to connect it to a different, pulling it all out of a database. It's a simple one-liner, but it might take 3 hours, right? It's a transfer. Your data set's really big. But the idea is you can separate operational efforts from the coding involved and the mindset of the person. Because a lot of times just finding those people that can do all that is really hard.
Absolutely.
It definitely just really reduces the amount of friction and inertia that your data has.
Yes, exactly. We kind of have this mindset of, we're trying to reduce silos. A lot of data reduce silos. People don't want silos. They want to connect data from multiple sources. And to get insights quickly, you need to be able to write ideas at a high level. Our big goal with Blaze is to turn the internet into a single database. Right? Doing there is going to take some effort. But that's the idea is why every data anywhere, any URL should essentially be like a table in a universal database. And you can access it from a Pandas-like API in Python.
That's definitely really cool. I wonder if you might say a few words about Wakari, because one of the things that really struck me when I came to the Python community was IPython notebook. I mean,
Yeah.
just this. It kind of, I don't know if you remember, I think you're old, just by the sound of your voice, you sound like you might be old enough to remember this. There was a cartoon years and years and years ago with Tennessee Tuxedo and Mr. Whoopi's 3D BB, this like magic blackboard that he could use to sketch out anything in animations, explain how things worked in the whole 9 yards. An IPython notebook really kind of reminded me of that, and the idea of being able to sort of like even add an additional dimension of that in the realm of science and data analysis and experimentation seems like it fits the metaphor even more fully.
Yeah, it's an amazing phenomenon. It's been awesome to watch it kind of emerge. And Fernando Perez and Brian Granger are both good friends of mine. We've been in this. We've been in this together. We often talk about how we're kind of old guard here in this fight for 18 years. But IPython actually started with Jenko Hauser, who wrote something called IPP that Fernando grabbed and used as the interface. And the key superpower of Fernando is he's constantly trying to figure out how to improve the user experience. And Brian Granger joined him with a similar desire. And there's a guy named William Stein who actually built an early version of a JavaScript front end to the Python kernel. And it's currently existing in Sage Math Cloud. So he has this whole Sage interface, which it's really geared towards the mathematician, to the kind of a replacement for Mathematica. But he's an amazing guy, and he's since adopted IPython Notebook as well. But he had that early thing in 2007, and that inspired Fernando and Brian to go, let's build this. But they architected around a kernel. Have a running kernel, then an interface that could be swapped out. But that interface has captured the attention of a lot of people. People recognize that it's a way to communicate information quickly. At Continuum, we've constantly been looking at what are the bottlenecks to really enable collaboration and shared understanding across a large number of people. Because to me, that's the secret to getting insight from data. You're not going to get insight from data because you just happen to get lucky. It really is about taking what you know and interacting with the data and iteratively exploring and talking to somebody else about it. And you want that process, that whole workflow to be as seamless as possible. So we knew about IPython Notebook, so have been very interested in kind of empowering people to use that more effectively and working with the IPython team to help them. So Wakari really was a notion of the notebook's great, but it's not enough. You have to have not only just the interface, you have to have your environment, your code environment. All the dependencies that are needed to run that workflow have to be available and installed for you. The data that workbook depends on also has to be available and installed for you, and you want it quickly available. So we started working on Wakari with those ideas in mind, and came up with kind of an initial cloud-based solution, and we also have an on-premise solution that we install. We're still iterating. We have a lot of things we're improving with that basic idea. Mostly right now we're resource constrained. We're looking to hire people because we don't have enough people to help us support the success we're having in some of these initiatives. So that's been a constraint for us. It's just getting the right people who can help. But yeah, so Wakari is all about, again, collaboration, helping people leverage the IPython notebook. So that phenomenon is a real one, and a lot of people have seen that it can change their approach. For some people, it's replacing Excel workflows, Excel workbook flows. They'll, instead of having a bunch of Excel sheets, they'll use an IPython notebook to express their work. Super excited about the future potential of it.
And I have one last question in the realm of projects that you folks have come out with. Numba, it's one of the things that I had actually learned about before I even actively started using Python, just because it made such a splash in the sort of general computing news. The idea of a JIT compiled, hyper-optimized Python for numeric computation is really, really super cool. And you talk about wide applications. I mean, that's being used in everything from obviously data science all the way out to games and, all kinds of areas. That really, it's quite an achievement. So what led you folks to build it, and what are some of the challenges, and where do you see it going?
It's a lot of fun. What led to it, honestly, was my desire. When I wrote NumPy, the first thing I wrote, actually, and remember I talked about SciPy starting with a bunch of modules I wrote? Mm-hmm. One of the first ones I wrote in 1998 was something called CFEs, which is a bunch of special functions. Things like array functions and Bessel functions and a whole host of these scientific functions that nobody cares about unless you're in physics, but then show up in various ways. I wanted all these available to Python users. And to do it, so NumPy has this thing called the universal function. But to build a universal function, you had to write C code. And I always wanted to be able to say, kind of have a Python expression of the function, and then create a NumPy ufunc just running Python code. So I've always wanted that, and I could never do it because, frankly, it needs a compiler. You need to be able to have a compiler that can take Python code and produce machine code to do that. So kind of with that in mind, I came across the LLVM library, and it really helped. It's a great library system. There's issues in terms of compatibility with back versions and so forth, but what it allowed is I saw a lot of companies like Apple and NVIDIA using LLVM as a common compiler framework, and realized there was an opportunity to use that to make the process of compiling simpler. I took a compiler course after I wrote the first version of Numba. Fortunately, Numba's had 3 revisions since then with a larger team and people with more compiler expertise than I had. But I was just crazy enough to think that I could do something once I had LLVM. Like I joke about, a compiler is easy to write if you don't have to write the parser or the code generator. And with Python, I don't have to write the parser because I get bytecode out of Python, and I don't have to write the code generator because LLVM does it for me. So it's really just translating bytecode to LLVM intermediate representation. There's still a lot of challenges, and most of the challenges are semantic and definitional in terms of what are we really doing? Because taking arbitrary Python code and making it faster is a really, really hard problem. You can't do it in general, right? What you have to do, you can have subsets of code, and particularly like the kind of code that uses NumPy arrays and scalars and just if statements and so forth. You can make that fast, and there's no reason to write Fortran or C if that's the kind of code you're writing. So it was recognizing that and saying, what can we do? Let's make progress in here. It was inspired a little bit by a conversation with the PyPy community. Some people think there's a conflict. There isn't a conflict. There's just different ways of looking at the world. I actually see a way forward to working with those folks now that maybe in a later point I could talk about. I'm pretty excited about it, actually. I wrote a blog post because PyPy was exciting to a lot of people. Wow, the future of Python can be compiled. It's awesome. But they were unaware of the deep roots of the numeric Python scientific computing ecosystem, and how connected to C code and Fortran code and all the C extensions that it required. Like, to really move that community over to PyPy would take an enormous effort, and they seemed unaware of that challenge. And so my approach is say, look, we'll start doing the other way. Maybe we'll meet in the middle somewhere, right? We'll start with take the NumPy SciPy community and start adding JIT compilation, and then add those features in that direction. So it's a different approach, the same problem. It's all possible, but again, how much effort it's going to take? With the right millions of dollars, we could do everything. But how do we do this in a community in a way that we can meet in the middle? And I think there's actually some really powerful solutions that could be accomplished if we work together.
I'll bet. It's really interesting that you say that. It really occurs to me that so often in technology we get this I'm going to do it this way, I'm going to do it that way, and it's like, whether it is that way or not, people assume that it's like, pistols at 20 paces, when in reality it's just a different approach to the problem, and it benefits no one to have this kind of bizarre, everyone is in constant competition. I mean, healthy competition, sort of like, I can do better than that is good, but,
Yes.
Not collaborating for the sake of partisanship makes no sense. I came from many years in Ruby. I learned Python, and all of a sudden I'm realizing you guys have some really cool toys in this side of the pool. I mean, it just makes sense. There's no reason to block yourself off from what other people are doing. It may not be what you would choose. It may not even be the right answer for you, but at least be aware of it and be open to it.
Totally agree. So actually right now I see a lot of in our future is integrating with the Java stack and with the R community, and with it's really a lot of people are trying to solve the same problems, and how do we do it in a way that's cooperative so we can share each other's successes? That to me would be the dream. It's difficult. There's some real challenges there, but there are also there are solutions at times, especially if you're looking for them, and very very transformative solutions if you keep searching. So that drives me. I'm excited about that. I guess maybe all computer programmers are lazy, some people say. We all want to just take advantage of other people's work. And that's certainly, SciPy was making available old Fortran code, bringing it back to life and connecting it to the modern user. And that was a big part of what made SciPy, and it's still a big part of SciPy. And you got to keep doing that. Let's instead of having to reinvent the wheel, let's figure out how to connect with each other.
So switching gears a bit, can you explain a bit about what NumFocus is and how that got started?
Oh yeah, I'd love to actually. So NumFocus, when I worked as a consultant, I recognized the challenges of being in a company and then also supporting community. Because I'm passionate about community, but I also am passionate about markets, and I have to feed my family, I have to have a job, and sometimes the pressures they cause people to be a little suspicious too. Like, oh, a company's doing this, what does it mean? And so I wanted to create an organization that was fully community run and funded and supported, so that if people had concerns, if you want to support companies. I think some companies are doing great things. Go buy their stuff, help them, make them successful. But there are other people who want to just support the community. So I wanted to make sure there was a place where Scientific Python could be community supported, and people could understand if they had any concerns, they could just focus on the community side. And then it also becomes a place that people can have different ideas in the marketplace. My company, your company, we have different ideas. We can cooperate together through an organization. So at the same time, if we found a continuum, I also found a NumFocus and got together with leading, with Fernando Perez and John Hunter and Perry Greenfield and Jared and Anthony Skopatz, and we created NumFocus as a community-centric organization, much like the PSF, much like the Apache Foundation, much like the Linux Software Foundation. Continuum basically hired an executive director and gave her full time to work on NumFocus. That was kind of our commitment to the community, and that's been a successful approach. She's been able to really rally a community around PyData, around the John Hunter Technical Fellowship, around Women in Science and Technology events, and really help that grow into a fiscal sponsorships for SymPy and for IPython and for several other projects. And then, eventually we're finally getting fiscal sponsorship for NumPy itself. One of the challenges is, as I step back away from NumPy, you leave a little bit of a vacuum, and then kind of there's a few people, there's like a committee of people who really make it work and keep running the NumPy and SciPy ecosystems, but helping them get a fiscal sponsorship together so we can fund them. So the mission of NumFocus is to fund the tools everybody uses and to be a rallying point for raising money to help these tools keep going. So it's a fully support. If it's a 501c3 nonprofit, you can jump in and participate as a member. You can donate. You can use your time. You can participate in one of the PyData events. There's a lot of ways to participate and become a supporter of the community.
That's really very cool. I think that so much. How should I say this? I look at so many technology stacks, like Linux is an example, Linux on the desktop, and I think to myself, it is such a shame that these folks can't come together and just agree on some standards, some interfaces. Like you can have a completely different way of doing things, but being able to come together and support the infrastructure that you both use and figure out a way to not inconvenience and fragment your user base, that's definitely a wonderful thing. It sounds like that's part of what NumFocus, in addition to offering fiscal support, is trying to do. Is that right?
Oh, absolutely, yeah. It's definitely a place where conversations can take place between projects, where people can know there's an interested body of folks who care about the overall experience and want to make sure that scikit-learn and IPython and NumPy and SciPy are all kind of talking together, even though they're independent projects, that they have standards and interfaces they agree on. A lot of that energy sort of happened. In fact, Fernando Perez, when we organized NumFocus, he had the thought of a confederation of federate groups coming together and having a place in a common organization. He used references to the founding of the country, actually, the United States of America.
Oh, wow.
You have these different states, and they all need to come together, and there be a group. And so, that's been a part of it, is figuring out how do we open source definitely has a community and an individual spirit, and it needs to retain that, but it helps to have organizations that are supportive of that, but a place for people to come together and take action together. And it's great to be involved, to have a legal entity that can take money, a legal entity that can employ people, a legal entity that can support if something, patents and trademark ownership and all those things that are important to associate with the laws of a particular country, but it can represent the community. There are challenges associated with it. Volunteer run is hard. That's why I've been grateful that we can continue to support an executive. Leah Silent is the executive director, and she's a driving force in the community, just as an actor who can continually move things along. Other companies are starting to give resources as well. So it's exciting to see. So it's really starting to take off, and I'm really pleased about the response of the community to organize to just helping sustain itself. Again, my passion has always been about, I love open source. I love to see it work. I love to see it sustained. I have 6 kids, right? And I had 3 kids when I was in graduate school. So from the very beginning of my involvement with open source, I've been aware of the need for me to provide for my family. And so I've had to figure out, how do we continue to do this and still put shoes on the kids' feet and put them through, now it's put them through college. And so that's been a part of what I wanted that for everybody. How do we make this work? And sometimes it's through community, and sometimes it's through companies. And I think both participate and work together to make it happen.
Absolutely. So for someone just starting out in the data science and, analytics space, what advice would you give?
Yeah, I would say learn Python as much as you can. I would say download Anaconda. I would say go and do a Google search on data analysis in Python. Learning basic data analysis in Python, and there's an enormous number of resources on IPython notebooks that'll just teach you, and you can walk through. I would say go to find a community, find a group, find a local meetup group, or find a local either PyData or a data science group, or even the R community can be helpful. You might go there and find a few like-minded, interested folks. You can take an online class, but get involved and then have something you care about. Like if you want to be doing data science, it means you want to transform information into a form to answer a question. So think, what do you want to do? So find a problem you're interested in and do the analysis, and and use that to guide your studies.
That's great. I think that'll definitely be some very useful advice to a lot of people, particularly because of data analysis and data science being such big industries now. And I've been reading a lot of things about how lots of companies are hiring for it. They don't have enough people to fill the positions that they are trying to fill. And so it's definitely a very lucrative direction for people to go in, whether they're just starting off in technology or just getting out of college, or if they've been in the industry for years and years and are just looking for something new to do.
It is. One reason Python's an excellent choice is, and don't be afraid to learn some programming. I think a lot of people find that the folks want data scientists, but they want data scientists who can program, who can put together a solution. We get a lot of applicants for data science roles. Our needs, like the number of needs where we want someone just to be analyzing data, are small. Where we want people to be able to take the problem somebody's trying to solve, again, because the tools right now are not where they could be and will be in 10 years. Today, they're still you got to do some integration. You got to do some gluing together of legacy solutions with legacy data, and that's going to take some programming. But Python can do it all for you. So just learn Python and become good at it, and don't be afraid to steer around. Maybe you're just interested in pandas and NumPy, but don't be afraid to learn a little bit about the URL request library or the other libraries in a parsing library, the scraping library. Don't be afraid to learn a little more and expand your knowledge.
So, of your myriad achievements and projects that you've been involved with over your life, what are you most proud of?
That's a tough question. I mean, honestly, it's my kids who I'm most proud of. That's a tough thing to say to a dad of 6 kids. His oldest is 20 and youngest is 7. It tells you how old I am. So beside my family, I would say jury's still out a bit. I'm certainly proud of what NumPy's become. Certainly, and realize, and mostly because of the effort it took to create it. And it was definitely it was one of those situations where I did not know the end from the beginning. Had to kind of leap of faith, feel this urge, feel this passion, feel this need, and take a step in the dark and without a lot of support, and then but have the confidence. And so and then have it emerge and be a real success. Definitely proud of that. But there's other things I'd like to be more proud of in the future. So hoping to replicate that in other projects.
That's great. So at the end of our episodes, we like to provide listeners with some picks. And so this can be anything that you find interesting enough to want to share with other people. So it could be technology, could be a movie, could be a board game, whatever it happens to be. So I'll get us started. So my first pick is going to be used bookstores. They are amazing. There's one actually down in East Lyme, Connecticut called the Book Barn, and I took my kids and my wife there recently, and we walked out with a giant box of books for about $100, which would otherwise probably have cost us about 5 times that much. So used bookstores are amazing for getting a lot of really good and interesting material for reading, whether it's fiction or nonfiction or kids' books. Just great thing to go out and do. Good way to spend the day. My next choice is going to be the movie Cloudy with a Chance of Meatballs. The book is a kids' classic, has been for years. The movie came out a couple of years ago, and it is hilarious. My 4-year-old loves watching it. He can watch it repeatedly, and I've seen it a few times, and I still think it's one of the funniest kids' movies I've ever seen. And then going on that theme for funny movies, another really great one is Kickin' It Old School with Jamie Kennedy. And I've watched that movie probably 8 or 9 times, and I still love watching it. It is one of the funniest movies I've ever seen. So for anybody who has even a tangential experience with the 80s, it's well worth a watch.
Awesome.
Chris, why don't you go ahead?
Alrighty. So this week, the first thing I'd like to pick to sort of continue along Tobias's theme of comedians is Kids in the Hall. For anybody who went to college around the same time I did in the sort of late 80s, early 90s, these guys are a Canadian comedy troupe, and they are just so funny, so bizarre, really great stuff. I mean, they've gone on to do lots of other great things. You probably know, if not them, then some of the work they've done in other venues, but they still make me laugh, out loud 20 years later. So that says something, I think. The next pick that I have is the Museum of Fine Arts here in Boston. Every year they do this really cool event called Art in Bloom, and it's really something kind of neat. Like every year they call in floral designers, oddly enough, to make floral designs and pair them with pieces of art all around the museum. So over the course of a weekend, you get to wander around the Museum of Fine Arts and see all these really kind of amazing, creative, cool floral designs paired with great art. And the Museum of Fine Arts has some really timeless pieces. So it's just a really great experience. It's sort of like a great evening or day out, and I highly recommend it. Then my next pick is Saran Bark and the Code Newbies community, talking about bringing people in and enabling people to do good work. There's been so much discussion out in our field right now about sort of like diversity and being welcoming to newcomers. And she, more than anybody else that I can think of, has really sort of like walked the walk. She's created a whole little empire of communities, sub-communities, I guess. She does a weekly Twitter chat. They have a Slack team channel room, whatever it's called. They have a discourse forum, and it's all oriented towards helping people get started with programming, and once they do, sort of like get their foot in the door and get that first job or get that dream job in software development. And just sort of like, and also she does a podcast that's totally amazing, and whether you're new or old or have been coding for 20 years like I have, it's really neat and worth a listen. So kudos to her and all the work she does. And my last pick, because I've been blathering on long enough, is the Apple 27-inch Retina iMac 5K, which I'm sitting in front of as we speak. I realize that this is going to out me as a total Apple fanboy, and that's okay. I love this machine. It is fast. The display is just as gorgeous as you might think. It's beautifully engineered, well put together, and just a real pleasure to set up, use. It has been a delight since I've gotten it, and I can't recommend it highly enough for anybody who needs a machine with a fair bit of horsepower under the hood, but doesn't necessarily want to go through the pain of building their own PC or supercharged PC or something like that. It's a really impressive machine. Travis, why don't you give us your picks?
Awesome. Wow. Okay. I'll start with Data Carpentry. Data Carpentry is basically an organization run by Tracy Teal, just getting off the ground, kind of after the pattern of Software Carpentry, which was very successful at training scientists how to program. Data Carpentry is about training people in various industries how to deal with data and how to manipulate it, how to use it. So it's they're just getting off the ground, but check them out, datacarpentry.org. Tracy's an amazing participant in the Python community. She was at PyCon this year with her family and has been a long-time supporter of Python. So that's one. Second one is I would say the Brain Science Podcast by Ginger Campbell, MD. She was a emergency room physician who decided that she really loved science and wanted to go back to her roots and started a science podcast. I love it. It's an old one. It's been out for a while, but you can still go there and get a lot of great book ideas about how the brain works, and I've just really enjoyed listening to her. And finally, a little bit maybe different, but a favorite book of mine is Money, Bank Credit, and Economic Cycles. It's a bit of a big book. It's pretty thick. It's not light reading. It's definitely for someone who's serious about trying to understand. But I feel like I understand the world much better. I understand financial systems and banking much better because I've read this book. He takes you through the history of money from the Roman days to today, and kind of all and how it works at a fundamental level. So really appreciate that. He's out of Spain. It's a Spanish professor at the University of Juan Carlos Madrid. Really appreciate that book. So that's it.
Great. Well, we really appreciate you taking the time out of your evening to speak with us. It's been a lot of fun, really interesting. So for anybody who wants to follow you in Continuum Analytics and the work you guys are doing, what would be the best way to find you and keep track of your...
Yeah, you can follow me on Twitter. I'm at TEOliphant, TEOLIPHANT. You can follow PyData at PyData, PYDATA. You can come to our website and follow at Continuum.io. So Twitter is easy. Facebook we post to occasionally. You can come to our website. We're at every PyData event, so look for PyData events in an area near you, and that's a way to kind of follow both the company and the community. Great. All right. Well, it's been a real pleasure. I appreciate everything you're doing. Thanks for inviting me.
Thank you for coming.